Okay, everyone, welcome back. So now we are talking about central tendency measures, the mean, median, and mode. So I'm on slide 4 of the descriptive statistics PowerPoint, where it says the mean. And the mean, the mathematical know-how required to calculate the mean, you picked up in third grade. All you need to do is add and then divide. So the mean is the arithmetic average of all scores in a data set. On this fourth slide, I've actually provided the formula. So how that reads is sum up all the values of the x variable and divide by the number of values you have. So this is a simple equation. Again, we're just adding and then dividing, and it accounts for every observation or score in the sample. So it's all inclusive and no scores left out. The disadvantage, though, is that if all scores are included, then that could also include extreme values, which are called outliers. And outliers can um, produce skew in your data set. And we'll talk more about skew in a couple minutes. Hopefully, some of that's ringing a bell from statistics that you took. So going on to the slide 5, I have here an example. So I took 3 different teams, college football from the fall 2019 season, and I've listed the past 5 seasons worth of victories for each season for them, most recent. So I have A&M, UT, and then the Gators. And if you would, go ahead and calculate the mean for each one of those. And you may want to pause the video at this time, and I'll pause a couple of seconds to give you time to do that. Okay, so now you have your mean values calculated, and you can take a look at the examples of the mean, and the results of those are on slide 6. Hopefully, you didn't move ahead and take a look-see before you calculated them on your own. But if you did, that's okay. So you'll see that the A&M mean is 8.00, Longhorns is 7.00, the Gators are 8.80. So that describes a typical number of wins in a season over the past 5 most recent years. Not in the history of their program or anything, just in the last 5 years. That's the typical number of wins they have in their season. Taking a look at the median, which is the exact middle score, so I'm on slide 7. The median in the road is the middle portion of the road where a lot of times it's concrete, sometimes they put bushes and landscaping in there, whatever. But a median occurs in the middle of something. So the middle score in the data set is the median. So the first thing to do is order all of your scores or observations from highest to lowest one at a time. Then find the exact middle value in that listing. So it's going to be the exact middle score. So you can determine that based on your this little calculation I've included, n plus 1 divided by 2. Please know that should be capital N for your sample. N plus 1 divided by 2. What that does is it basically splits the sample in 2 equal halves. So the exact middle value, when you count up that number of slots from the bottom or down from the top, that actual number listed there is your exact middle point. The only difference is if the even numbered data set is one that's in front of you, you'll have to take the mean of the 2 centermost observations. So the advantage of a median is that it's not affected by outliers. You could have those extremes in there and they don't impact the median. The disadvantage, though, is that because it's not as stable as the mean, because it doesn't completely take into account every single value that each score brings in. So the example of median I've listed here on the next slide is Mario Lemieux, and I actually listed it from lowest number of goals scored in a season to highest. Normally I would do it from highest down to lowest, but it's as long as they're in order, you'll get the median right each time. So I've listed the median on this slide, 44. Uh, in a typical season, that's how many goals he scored from a median standpoint. Pretty good. 82 games in a season, he's scoring in most of them.